Hello everyone! Today we will continue our discussion for the derivatives of exponential and logarithmic functions. In this lesson, you will be able later to find how to derive it and also apply the product rule, the quotient rule, and also the chain rule for exponential and logarithmic functions. Let's see the first one, how to derive the exponential function. Exponential function is symbolized as e to the power of x. This is also known as the natural exponential function. E itself is actually a constant which value is around 2.71828. From the first principle of dy dx, which is the limit of delta x approaching 0 of delta y over delta x, it will be derived that the derivative of e to the power of x will be also e to the power of x. So the discussion of how it is obtained is not discussed here, but if you want to know, we can discuss it later. Let's see example 1. If e to the power of x, the derivation will be still e to the power of x, what about y equal e to the power of 2x plus 1? So in here, 2x plus 1 will be symbolized as u, so that what we have is y equals e to the power of u. We will apply the chain rule that dy dx equals dy du multiply with du dx, so that the dy du is the derivative of e with the variable of u will be still e to the power of u. And then the du dx from 2x plus 1, we will have du dx is 2. So that dy dx will be, let's change u back to 2x plus 1. So we have 2 times e to the power of 2x plus 1. So in general, when you have y equals e to the power of u, where u is the function of x, then we can have the derivative of e to the power of u is e to the power of u. Here we differentiate the e, and then after that we multiply it with the u prime, which is the derivative of the u. So for example, if u is ax plus b, we will have e to the power of ax plus b multiply with a, which is the derivative of ax plus b. Let's use it in example 2. Differentiate each expression with respect to x. Here, e to the power of 2x plus 1 is multiplied with sine x, so we will apply here the product rule. By the product rule, we have u is e to the power of 2x plus 1, so the u prime is 2 times e to the power of 2x plus 1, and then v, which is sine x, so that the v prime is cos x. By u prime v plus uv prime, we will have u prime, which is 2 times e to the power of 2x plus 1, will be multiplied with sine x, and then it will be added by the u, which is e to the power of 2x plus 1, multiplied with cos x. And we can simplify, take out e to the power of 2x plus 1, and we have in the bracket 2 sine x plus cos x. Now let's discuss the b part. In here, you can see that e is separated in numerator and denominator. So before we proceed with the derivative, let's simplify this by using what we have in indices law. So in indices law, we have a to the power of p divided by a to the power of q, and the power will be the subtraction of p minus q. In here, since e is also a constant or the base, we can change it become e to the power of p divided by e to the power of q will be e to the power of p minus q. So that in here, we can simplify first by having the index law of 3 multiplied with 2x, since both of them are power. And then, now let's apply, subtract the power, so we have 3 e to the power of 6x subtracted by 7x minus 2, and we have it simplify become 3 times e to the power of minus x plus 2. So now we will have e to the power of u which derivation will be e to the power of u multiplied with u prime. So in here, dy dx become 3 multiplied with e to the power of minus x plus 2. So this is the e to u, and it is multiplied with minus 1, which is the u prime, the derivative of minus x. So dy dx become minus 3 times e to the power of minus x plus 2. Let's go to the 19.2, the derivative of logarithmic function. In here, if fx is e to the power of x, then log x to the base of e will be the inverse of f. And the log x to the base of e usually written as ln x, the natural logarithm of x. Now, how to differentiate the y equal ln x? In here, the function of y equal ln x can be written as x equals e to the power of y. So let's derivate x and e to the power of y. In here, when x is derived, the result is 1. And when e to the power of y is derived, we will have the chain rule. So we will derivate it in terms of y first, and it will be multiplied with dy dx. So the derivative of e to the power of y will be still e to the power of y, and then it will be multiplied with dy dx. Since e to the power of y is x, so we change it back to x, and we have 1 over x is dy dx. So that the y, if y is ln x, then the derivative of ln x will be 1 over x. So now we already derivate the ln x. Now let's continue. What if we have y equals ln of a function u, where u is a function of x, then we will apply the chain rule again. Dy dx will be dy du multiplied with du dx. So if y is ln u, then when we derivate ln u with respect to u, we will have to multiply it with du dx. The derivative of ln u is 1 over u, and then it will be multiplied with du dx, or we can have the u prime divided by u for derivative of ln u. If u is ax plus b, so we have the derivative of ln ax plus b become a divided by ax plus b. Now let's try example 3 by using our formula. Let's differentiate this expression with respect to x. Ln 1 plus sine x. In here, we let u become 1 plus sine x, so that what we have for the u prime is sine x derivative become cos x. Then, using derivative of ln u, which is u prime over u, then we will have the u prime is cos x, and the u is 1 plus sine x. So this is the result of example 3 part A. Now let's try the B part. Let u is ln x and v is x plus 1. In here we will use the quotient rule, so that the u prime is 1 over x and the v prime is 1. So using u prime v minus u v prime over v square, we will have u prime is 1 over x multiplied with x plus 1 subtracted by v prime is 1 multiplied with ln x. So that we divide it by x plus 1 square and simplify this by multiply all terms by x. So we have x plus 1 minus x ln x, and we can take x out so that it becomes x times 1 minus ln x plus 1 over x times x plus 1 square. Last one, example 4. Differentiate ln 1 minus 2x divided by 1 plus x with respect to x. So let's recall our formula for the logarithmic. Log a per b can be simplified come log a minus log b, so that when the base is e, we can also apply it here. Ln a over b is ln a minus ln b. So that for ln 1 minus 2x over 1 plus x, we can make it become ln 1 minus 2x subtracted by ln 1 plus x. Now, we can have the ln u formula and having the derivative of ln u, which become u prime over u. So in here, the u prime is minus 2, and it will be divided by u, which is 1 minus 2x. And then, for ln in here, the derivative of u in here is 1, and then the u itself is 1 plus x. Now we will simplify these two fractions. We cross multiply and make it the same denominator and simplify so that we have minus 2 minus 2x minus 1 plus 2x over 1 minus 2x times 1 plus x. So the final result will be minus 3 divided by 1 minus 2x times 1 plus x. So we finish example 4, and that's all for today. Our summary for the formula is this all formulas here. So later you can apply in a specific problem which is related. Thank you all by watching this video until the end. God bless you and bye-bye.